A steam plant using a rebuilt Stuart 10V steam engine. Part 3. Continuing assembly of the Cleveland Steam Pisces Babcock type boiler. Fitting the boiler fittings and mounting the boiler on the frame. In the next episode I'll be test steaming this boiler, but first of all it needs the fittings putting in place. On screen from part 1 of the series is the complete kit before I started assembling it. And right in the middle, just underneath the boiler, is a bottle of nut lock. It's called SAS nut lock. And in the following video, with the exception of the bolts that hold the boiler frame together and the threads on the safety valve, every boiler fitting and parts for the burner will be covered in a coating of this nut lock. This will prevent steam leaks. It's very similar to Loctite 542, but a little bit stickier. This is one of the 2 brass blanking plugs, and these will be fitted in place using a socket driver, but I don't really need to fit them that tight. In fact, at this stage I'll quickly mention that when you're assembling miniature things like model boilers, model steam engines, do not put too much pressure on the fixings and fittings. Remember, you are not fitting a cylinder head to an internal combustion engine. A torque wrench is definitely not needed here, just gentle, firm pressure. After fitting the blanking plugs, now I'm fitting the water gauge. And once again, all of the threads are coated with the nut locker provided with the kit. This stuff is quite good because it allows you to fit a part and then readjust it, and it grabs again. Whatever you do, never use Loctite 603 or similar retainers to fix parts like this. You really are asking for trouble doing that. This nut locker and Loctite 542 is perfect. I found fitting this water gauge to be difficult. The O-rings are not silicone. They're quite hard and very difficult to push onto the glass tube. And then they are also difficult to push into the nuts. You need to use a lubricant for this, and I recommend saliva. It's surprisingly good. Whoever would have thought that evolution made it possible to use saliva as a lubricant when assembling a miniature steam boiler? Here's the glass fitted in place. All I need to do now is tighten the nuts at the top and bottom. It doesn't really matter which nut you tighten first. I chose to tighten the bottom one. In this part of the clip, I'm tightening the top nut now. Before fitting the top cap to the water gauge, I fitted the pressure gauge and siphon. After that, I fitted the top cap of the water gauge using my socket screwdriver. This part is important. Always use 2 spanners when you tighten the union nut onto the pressure gauge. If you don't do it this way, you're very likely to damage the internal workings of the gauge. I fitted the steam tap early onto this boiler. A quick note. The nut lock is ideal for all fittings except for the safety valve. That needs to be very easy to unscrew. I'm applying 70 pounds per square inch to the boiler. The boiler's test pressure is 60 pounds per square inch. And here I'm adjusting the safety valve to make it blow off at 60, not 70 pounds per square inch. It's not a good idea to overpressure the boiler, but the boiler has had a hydraulic test to twice working pressure at 120 pounds per square inch, so it's quite safe. By now the silicone sealant, which is holding the heat insulation to the side panels, has cured. It's time to assemble the outer casing. First of all, I screw one side in, 3 M3 bolts at each side. Then I sit the boiler in position, holding it there sat on the piece of brass bar while I screw in another M3 bolt into a bush in the end of the boiler. So the last thing you need to do is over-tighten it. With just one M3 bolt left to be tightened at the bottom left, the outer casing construction and boiler support is now finished. You may have noticed in the previous episode that when I stuck the heat insulation to the side panels, there was a little bit sticking out at the top, and now it's time to press that down into position. The reason for this is you don't want to see the heat insulation, nor do you need a gap around the edge. All the products of combustion will go up the chimney. And while I'm on the subject of the chimney, I'm about to fit the brass cap. I've coated the inside area of the cap with some nut lock. I spread it out around the inside edge of the cap. Now all I need to do is tap the cap into position. As you can hear, for this job I am using a small hammer, but at both ends of the chimney, at the cap end and the other end, are pieces of wood. This is a very quick and simple job. I refitted the chimney to the boiler, and as you can see in this clip, the brass cap finishes off the job beautifully. Now it's time to verify the burner assembly. This morning, whilst I was having my breakfast, I was actually reading the instructions, which explained how to set up the burner jet distance using a 2.5mm drill bit. Although previously I didn't do it this way, I thought I'd better follow the instructions. So here, one side at a time, I fit a 2.5mm drill bit between the jet and the edge of the venturi tube at both sides. And after tightening the 2 stainless steel pinch bolts, the job is done. Time for a test. Here's a can of gas connected to the burner. All I need to do is open the valve on top of the can whilst holding a lighter over the gas. Both of the burners light, and I will take this opportunity to recommend that when you light the burners, keep the gas pressure low. To start with, it's a bit on the high side. And because these are not ceramic burners, it's very easy to blow out the flame, particularly if the gas pressure is too high. More about this after the steam test in the next episode, but that's it for now. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.